So today we are going to learn two-pointer technique and hashing. So based on this technique, I have already a video in another playlist called logic building. So you can go there and you can watch the video. And if you still think like you have not understood that, then you can come here because this playlist is going to contain a longer video. So this playlist name is logic building long video. So for the same problem I have already solved in a playlist called logic building. I'm going to solve here again with the explanation. So here in this video I'm going to use programming language golang for the solution. So let's understand a problem based on this two-pointer and hashing technique. So let's see the problem. Yeah, so the problem is it's a two sum, and here it's saying like given an array of integers nums and integer target, return indices of the two numbers such that they add up to target. Okay, so if you see the nums input, there are two inputs. One is the array and another one is the target. So if you find the item like 2 and 7, then target is 9. So in this case we want to return this indices. So it's a 0 and the 1. So that's a problem. So let's see how to solve this using brute force technique. So through the brute force technique, let me copy this and I'll explain this. Okay, so this is the problem: 2, 7, 11 and 15. So what we are going to do, we are going to run two for loops. So one is outer for loop and inner for loops. So in the outer for loop, we'll fix the pointer, that's a 2, and then the inner for loops take all the items like 7, 11 and 15. So let's say I can fix the I here and then j here. So I is 2, j is 7, 2, 7, add and check whether it's equal to target or not. So we are lucky that we found the target here, but in the case if we do not find the target, then we can move the pointer j. So first the j was here, and then we can move the j here and j here, and we can add these like 2, 7, 2, 11, 2, 15 and check with the target. And if you find the target, then in that case you can return indices. So that's a brute force, but we know there are two for loops over there. So let's do this example. Okay, so let me copy this example once again. That's the examples here. So let's create a array. So for this array, it's a nums. So nums 2, 7, 11 and 15, and target is 9. Okay, that's good. Then I'm going to have a function. So we can have like similar function. We can copy this. Okay, it's a two sum name. Okay, so I will write another function because I'm going to write in a golang, and I'm going to follow this naming convention. So it's a func to sum, and this is supposed to return the array of indexes. So and the input parameter will be nums and target. So it's a nums, and nums is array of int, target int, and it's going to return array of indices. Okay, so we can call this function here. You can pass nums, you can pass target, and whatever it returns, we can put in a result and print the result. Okay, so that's good. So in the two sums, we are going to use two for loops, one outer for loop and one inner for loop. So for I equal to 0, I less than len of nums, and I plus plus, and then you can start the other pointer from the next item. So you can say I plus 1 and j less than len nums j plus plus. Then we can add the two items. So it's a nums I plus nums j, and you can check here like if nums I and nums j equal to target. So if it is target, that's a then we that's a result. We need indices. So result, I can have another variable result interfere, and then we know the indices we need is I and j, so I can have that here. Result so I, and also we need a j. And we can return this result. Let's run this. Line number 22. Let's see what's the error. So we need a for loop, so there is no for, that's why it's complaining. Let's save it and run again. So we can see the result is 0 and 1, because we know the first index is 0 and the second index is 1. So our two items are index 0 and 1. So this is a brute force solution where we can find the target. We can find the target here. So but if you see there are two loops. So if you consider this in a terms of big O notation, so this is n square. So we need to improve this. So the way we can improve this solution is the either two pointer technique, or we can have the hashing technique. So first let's see the hashing technique, and let's see how will you improve. But before that, let me change this name to some, let's say, brute force, and I can call this function here. Okay, that's good. Let's understand another approach, like hashing approach, to solve this problem. So for the same problem, if you use some hashing technique and then try to solve, then you can solve this in a like with a one for loop with the order of n. So in a if you like if you see the if you take an example for Java, there is a set, so or set and map. We can so in a set or map, we can store the key, and that key is going to be unique. So in a Golang, there is a map, and in a map, this that stores two values, key and value. So in a map, so if I so in a map, we can store key and value. So in this case, what we do, we'll iterate each item, and we iterate each item. In that case, we can have one for loop, and in a one for loop, we get the first item. And what we do, we have like map, and in a map we can store this item 2. First time we can store 2, so that's good, it will go there. We know that the hashing, in a hashing approach, this key cannot be duplicated. So the next time when we go and we try to put this 7 here, first we'll try there is like the target is 9, so 9 minus 7 is already here or not. So we know that 9 minus 7 is a 2, and the 2 is already here. So when the pointer was at 7, we check this condition, and we found that okay, this 2 is already here. So the one pointer, so this 2, so for this 2, we already store here, and for the 2, we know what is the index for this. So for the 2, index is 0, so we can also store the index 0. And when the next item comes in a for loop, that is 7, so in that 7 we already found like 9 minus 7, 2 already exist. So in that case, we know the index of 2 is here, and the index for 7 is 1, and that is the answer. So that's the approach we are going to use in a hashing technique. So based on this, we can have just a one loop, and then we can have this map. And you know that from the map, if you insert and if like remove, if you delete the stuff from here, this is order of 1. So we can do that in a constant time. So let's write the program for this. So I can define another function to sum passing nums int and target int. It's going to return the same thing. You can call the function here. Let's print one line. Call this function, pass nums and target. Can store that in result, print the result. Using hash. Okay, so first thing we have to define a map for hash. So let's create a variable, and the way in a Golang we define the map is make map, and the key for the what is the type for the key, so that's a int, and also value is also int. So this is the map. We defined the variable. Now let's have a loop here. So for loop, so I equal to 0, I less than length of nums I plus plus. Okay, so first thing, what we do, okay, as soon as we get this item I equal to 0, so from nums I, so we store that in a map. So m so nums I, so nums I, that's going to be key here, and the value will be index. Okay, so value is index. So we store this key and value, and before this also we can check like if nums I, so nums I, that is, so what we see here in this example, let's go back and check like we did, the target, we are checking this thing, target minus the value. So first time we'll check 9 minus 2 whether exists that or not, 9 minus 7. So we'll use the same logic here. So what will it do is a target, so let's say target minus nums I, and we can check whether that exists in a map or not. So we can use the map here, map, and it can return in a two. We can check how we check whether it exists or not. So in that case we will return, this will return 2 items. So I'm just having underscore because underscore, do you need that? Yeah, if it exists, then okay, so we need this value also. Let's say I can put that index 1. If it exists, that means index 1, and I can check like if okay. So that means if okay, that means target minus nums I exists in a map, and if that exists in a map, that means we need that index and the current pointer. So current pointer is I, so that's our result. So in this case we can say return int and first, or yeah, index 1, and then current index. The current index is I. Yeah, that's all. At the end, like if we do not find we do not find the target, then return the empty array. Yeah, let's try to run this, save it. Result using hash, still we have same result 0 1, so it's a 2 hashing. Okay, so let's try to solve same problem using 2-pointer techniques. So let's understand first how we'll use the 2-pointer techniques, and then we'll come back and write the code. Okay, so let's erase this. Okay, for the 2-pointer technique, the requirement is this array must be sorted, and if it is sorted, then the 2-pointer works here. So in this case we know this is already sorted to 7 11 15, and this is sorted, so in that case 2-pointer works. So in a 2-pointer approach we have one loop, and in a one loop we fix the first pointer in the beginning and the last pointer at the end. And what we do, we take this item, first item and the last item, and we add this item. So we'll take 2 and the 15. So the 2 15, that's a 17, and then we'll check. Let's write this. So it's a 2, and we'll check. We'll take the 2 first and the 15, and then it's going to be 17, and we'll check this like 17 is equal to target or not. So if it is equal to target, then in that case we found our if we found our indices. So like a first pointer and the last pointer. But in this case, if it is not the target, then we can check whether this 17 is the less than 9 or greater than 9. So in this case, we'll see that 17 is greater than 9. So the greater than 9, that means the right pointer we can move left side, because the number is sorted. So that means if you add this item 2 and 15, then it's a 17. And if you move your pointer in this side, right to left, then the pointer comes at 11. And then if you add the 2 and 11, then it's a lesser number than 17. So if you move this direction, it's a lesser number, because we know this 215 is 17, and then our target is 9. So we need the less number, not the bigger number. We need the lesser number. So for the smaller number, we have to move this pointer into right to left. So it will come in this approach. The pointer comes 11, and then we'll check again. 2 11 is 13, and the 13 is greater than 9. So we need a smaller number to move the pointer to this place. And the 279 is the same. Then we can return the indices because we found the result. So in the similar way, let's say we are finding something like let's say our target is something 15. So if the target is 15, okay, so if the target is 15, how does this work? So do we have the target 15 of the 2? No. So let's find something, the 7 and 11. It's 18. So make it 18. Okay, so that's 18. It's a 7 and 11, so 18. So in this case, like if you fix our pointer in the first place 2 and then 15, and we'll add this 17, and we'll check whether it's equal to 18 or not. So it's not equal. Then we'll check whether 17 is less than 18 or greater than. So in this case, 17 is less than 18. So if it is less than 18, that means we need a bigger number. So in that case, we can move this pointer to 7, because in the first time the pointer was at 2. So next time our pointer will be at 7. So then we'll again add, like it's a 7 plus 15. And it's a 22, and we know that our pointer is, one pointer is here and another pointer was here. Okay, so we'll check. It's a 20 equal to our target 18? No, it's not equal to target. Then we'll see that, okay, 22 is less than 18. The 22 is not less than 18. 22 is greater than 18. If it is greater than 18, then we need a smaller number. Then we can move the right pointer to left side. So this time we'll move this pointer here. And that's gone. Okay, so this time we'll see 7 and 11. It's a 18. So we found 7, 11, 18, and we found the target, and that's our answer. Okay, so in this this is called two pointer approach. Let's write the code for this. So we'll have the similar function found to sum two pointer nums int target int we can have two pointer here. So let's say I equal to 0 and j, that's going to be end. So it's a length of nums minus 1. So that's a pointer, and we can also check a condition in a loop, like for I less than j, because when you move the pointer I to the right side and j to the left side, then there is a situation where the I will move to right and j will move to like left. In that case, I value is greater than j, and then just we want to come out. So as long as I is less than j, then we can increment and decrement the pointer, so left and right. Okay, so that's good. Let's check here if it's a nums I plus nums j. So we can also, it's a better, like we can have in a variable called sum, and we can check here if sum equal to target, then we found the result. So in that case we can return array of the indexes so that's I and j. That's good. If you do not find, then we can check the condition else if sum less than target. So if it is sum is less than target, then we'll increment the I, because it's a sum is less, we need bigger number. It's a less than target, then sum is less than target, we need a bigger number to check whether it's equal or not. So we'll move the pointer left pointer, it's the I plus plus. Else in other case, if we'll decrement the right pointer, so j minus minus. If you do not find the result, return the empty. Okay, let's run this. Result using two pointer. Can pass nums and target. Let's run this. Didn't print the result. Okay, so that's also 0 and 1. Yeah, so we fixed this solution with three different approaches. Yeah, so yeah, that's all for today. And once again, if you want to see the like a small video for this, you can jump to the another playlist called logic building. Okay, see you in the next video.